Which of the following reactions of glucose can be explained only by its cyclic structure? Glucose forms pentaacetate. See, if I just talk about the formation of pentaacetate from glucose, so it's basically CHOH whole thrice, fine. Then this is CH2OH. I should rather over here write CHOH4. Fine. So when it reacts with acetic anhydride or acid chloride, CH3 C double bond O, O C double bond O, CH3, this is acetic anhydride, or acid chloride, CH3 C double bond O, Cl, there is formation of glucose pentaacetate, CH3 CHO, then this is CHO C double bond O, CH3 whole 4, and this is CH2O C double bond O, CH3. So this is pentaacetate of glucose. You can just have a look that we do have 5 acetate molecules being joined into glucose. So this is pentaacetate of glucose. Pentaacetate of glucose. So talking about ki if this reaction can explain the cyclic structure, no, this reaction is not explaining the cyclic structure because the open chain structure is actually giving us the pentaacetate of glucose. So this is actually not explaining the cyclic structure. Now glucose reacts with hydroxylamine to form an enzyme, to form an oxime. So yes, so it's CHO, then this is CHOH whole 4, and then this is CH2OH. This is glucose. So when it reacts with hydroxylamine, NH2OH, we actually get CH double bond NOH, CHOH whole 4, and this is CH2OH. So basically this is glucose oxime. This is glucose oxime. So this is also not explaining the cyclic structure because हमें glucoxime मिल रहा है, glucose oxime मिल रहा है. Glucose reacts with hydroxylamine to form an oxime. तो ये वाली बात भी सही है, and it's not explaining the cyclic structure, rather it is explaining the open chain structure. Now pentaacetate of glucose, this is pentaacetate of glucose, and this pentaacetate of glucose, this does not reacts with hydroxylamine. ये hydroxylamine के साथ reaction show नहीं कर रहा है. So if pentaacetate of glucose is not reacting with hydroxylamine, it means there is absence of aldehydic group. क्योंकि यहाँ पर आप देखिए ग्लूकोज का जो हमारा ये aldehydic ग्रुप था, दिस इज CH डबल बॉन्ड O, एंड आप यहाँ पर आप देखेंगे इट्स H2NOH. तो यहाँ से ये पानी निकल गया और हमें ग्लूकोज ऑक्साइम मिल गया. ठीक है. सो ग्लूकोज ने रिएक्शन शो किया हाइड्रोक्सिलामीन के साथ, लेकिन pentaacetate of glucose is not showing reaction with hydroxylamine. This means that there is absence of CHO group. अब absence of CHO group तो एक ही condition में है when we talk about the cyclic structure of glucose. When we talk about the cyclic structure of glucose, I think you got my particular point what I literally want to talk over here. ठीक है. सो साइक्लिक स्ट्रक्चर ऑफ ग्लूकोज आप अगर देखेंगे, सो दिस इज द साइक्लिक स्ट्रक्चर ऑफ ग्लूकोज. इट्स HOH, फाइन. सो दिस इज HOH, HOH, then over here it will be OH, then over here it's HOH, एंड इधर है हमारे पास में CH2OH, एंड यहाँ है ये H. तो ये हमारा साइक्लिक स्ट्रक्चर है किसका? ग्लूकोज का. यहाँ पर व्हाट यू आर सीइंग, इज देयर एनी प्रेजेंस ऑफ एल्डिहाइडिक ग्रुप? नो, देयर इज नो प्रेजेंस ऑफ एल्डिहाइडिक ग्रुप. Fine. So since hydroxylamine is not reacting with the pentaacetate of glucose, it is actually explaining us the cyclic structure of glucose basically. So option number 3 is the right answer. Glucose is oxidized by nitric acid to glucaric acid. This is absolutely right, and it is actually explaining the open chain structure. So let me talk about it. So glucose, ये हमारा ग्लूकोज है, इसकी रिएक्शन अगर मैं नाइट्रिक एसिड के साथ में करूँगी तो मुझे बेटा ग्लूकारिक एसिड मिलेगा. दिस इज CHOH whole 4, and this is COOH. This is glucaric acid, explaining the open chain structure. So the right answer to this particular question is only option number 3, That's all.